Hello, and welcome to this tutorial for BioXTAS RAW. In this tutorial, we will learn how to use RAW to analyze size exclusion chromatography coupled to SAXS data. Before we get started, I just want to talk a little bit about what this kind of data is. So in a typical SEC-SAXS run, images are collected continuously while the eluate, or outflow, of a size exclusion column flows through the SAXS sample cell. As proteins scatter more strongly than buffer, if you look at a plot of the total scattering intensity for each data point versus time, you end up with something that looks equivalent to a UV chromatogram. This is the so-called SAXS chromatograph or scattergram, and we'll see peaks where the protein comes out because there's more intensity there. So the basic mode of analyzing SEC-SAXS data usually goes like this. You take all the frames that you collect in the experiment, you first plot them as this total intensity versus time, or if you don't have a time calibration, total intensity versus basically index of the data point. You then define a buffer region, subtract it from everything, look at the subtracted data in the same way, look at the RG and the molecular weight across the peak where the protein's coming out, pick a good region of that peak, average the data in that good region, and then that creates a single subtracted scattering profile. It's the average of all your good data, and you do the rest of your analysis on that. So that's the big picture overview. It'll hopefully make more sense as we go through the tutorial. So to start with, this tutorial uses the raw tutorial data, which is available on the raw website, and we're going to use the data that's in the sec data folder. So I'm in the Files tab, I'm looking in the sec data folder. We're going to start with sec sample 1. So what you should see in this folder is you should see about 1,000 scattering profiles in the standard .dat format. So these are already radial integrated. You can see there's 964 of them, 965 because we start at 0. And these are one-dimensional scattering profiles ready to load into RAW. Each one represents one particular time point in the size exclusion chromatography elution. So to load them into RAW as this series, we select all the data, and then we click Plot Series. It's very important to plot the series and not just plot them, because if you try to plot 1,000 scattering profiles in RAW, you may end up crashing the program. So once we click Plot Series, what RAW does is it loads in each individual scattering profile, and then it calculates the total intensity for that scattering profile. It integrates the scattering profile, and it creates a curve on the series plot, which we're seeing here, where it's plotting the total intensity for each profile, and then it's plotting that versus the profile number. So this is essentially the SAXS equivalent of a UV chromatogram. We have this nice flat region where the buffer is coming out of the column. Then we have a peak where the protein comes out because protein scatters more than buffer. Then we come back down to the buffer level. If we go to the Series tab in the control panel, you'll see that we've loaded up a series, which corresponds to the series shown on the plot. Now it turns out that the first data point of this series is actually a little bit odd. If you click on these pan button down here, these crossed arrows, you can then click and drag on the plot to move the scattering, or to move this plot around. And you can see that this first point is actually quite a bit lower than the rest of the data set. There's just something a little bit fluky about that collection, so we're going to replot the series without that data point and exclude it from our analysis. To do this, we go back to the Files tab, we select all the data except the first data point, and we click Plot Series. If we go back to the Series tab, you see there's now a blue and an orange curve. If I click on the pan button again and I click and drag, what you'll see is that there's this orange curve doesn't have this dip at the beginning, so we've excluded that first data point. If you want to return to the standard axes that it was plotted on, you just click Home. So I'm going to remove the first data that we loaded in, and now we have just this single series again. in orange, where you can see the buffer baseline on either side of the peak and the protein peak here. So in some cases, it's useful to look not just at the total intensity of the scattering profile, but perhaps at the average intensity or at the intensity at some particular set of Q values. So if you right-click on the plot and you move your mouse over the Y data left axis, it pops up a menu. You can change the type of intensity that's being plotted. So we could select integrated intensity, which is what we have now. We could decide we want mean intensity, the average intensity, or we could decide we want the intensity at some specific Q value, for example 0.02, or the intensity in some Q range. I might pick 0.01 to 0.08. On the whole, I think that integrated intensity is usually an appropriate way to look at it, so I'm going to go back to looking at the integrated intensity. The next thing we typically want to do is we want to examine more closely the elution. So what we're going to do is I'm going to click on the zoom button down here, the magnifying glass, and then that allows me to click and drag on the plot to zoom in. So I've now zoomed in on the base of this plot. I'm going to click again on the magnifying glass to disable it, click on the crossed arrows to drag the plot a little bit to adjust my view. When you have this pan tool selected here, you can also left click and drag to adjust the range of the plot. So I'm going to just adjust this a little bit to make it more clear what's going on. And I'm going to deactivate the pan tool by clicking on it. So what we're seeing here is just the very base of the solution peak. This bit to the left over here, this is buffer. Then you see we have kind of two smaller peaks coming out, then the main peak, and then it comes back down to buffer. So these two small peaks are very important. We should keep in mind that they're there. And you also notice that the buffer doesn't quite match up between the two different sides. So we have to bear that in mind in our analysis as well. Now, in order to determine if we really have a single monodispersed species eluting across this peak, what we're going to do is we're going to calculate the radius of gyration and the molecular weight from the SAXS data as a function of the frame number. And we're going to look at that plot across the peak, and if it's all equal across the peak, then we know we have the same thing everywhere in the peak. And if it changes across the peak, then we know that we have something different at different points in the peak. So the way we're going to do this, we're going to start by right-clicking on the series in the Series tab and selecting LC Series Analysis. So this opens up a new analysis window. You see there's plots on the right, there's controls on the left. So right now the plot that we're on is showing the same thing as what we were just seeing in the series plot. This is the total intensity of the unsubtracted data set. We can change which intensity we plot with the tabs up here, with this drop-down menu. And over in the control panel, you'll see that we have various controls. We can set some things for the molecular weight calculation, but most importantly, we can actually set a buffer region. So in order to calculate the radius of gyration and the molecular weight, we need to have buffer subtracted scattering profiles for the protein. So what we're going to do is we're going to initially define some region as the buffer. We're then going to create an average buffer profile from all the scattering profiles in that region. We're going to subtract that from everything in the data set, and that'll give us a set of subtracted scattering profiles that we can use to calculate the radius of gyration and molecular weight. So the easiest way to do this in RAW is to start out by clicking on the Auto button. This is going to try to automatically find a good buffer region to use for our data set. And you can see that once I click it, this green region appears on the plot, and we get a region in this list here, which tells us the start and the endpoints. In order to make sure that RAW's actually automatically found a good region, because it can get fooled by certain types of data, I'm going to click on the zoom button, and I'm going to zoom in near the base of the plot. Oh, I must have misclicked there, sorry. Zoom in near the base of the plot. So you can see that this buffer region is selected in this nice flat region here, and it's before the peak starts coming out. So RAW's done a pretty good job in this case. If we wanted to fine-tune the ends of this range, we'd come over here, and in this start and end boxes, we can either use the arrow buttons to adjust it up or down, or we could type directly into the box and give it whatever value we wanted. In this case, I'm happy with how the auto selection did, so we're just going to stick with that. I'm going to zoom back out to the full extent of the plot. That's just clicking the home button. And now that we're happy, I'm going to set this buffer region. So we click Set Buffer. What this does is it averages all the buffer in that region, and then it subtracts it from every scattering profile. It subtracts that averaged buffer profile from every scattering profile in the data set. So what we see now is we've switched to the Subtracted tab up here. This is now a plot of the intensity of each subtracted scattering profile as a function of frame number. And you can see that out here in this flat region, where it's all buffer, we have buffer subtracted from buffer, and we have a total intensity that's about 0. That's what we'd expect. We can see these little peaks, and then we can see the main peak, and then on the right, as we notice, the buffer there isn't quite identical, so there's a little bit of signal there. The other thing this does is after it creates the subtracted scattering profiles, it goes through, and for each scattering profile, essentially, it tries to calculate the radius of gyration and the molecular weight. It isn't actually quite every scattering profile. What RAW does is it takes an average window of size defined by this average window size here, and it slides that along the curve. So it'll take frames 1 to 5 and average them, and then try to calculate the RG and molecular weight for that average set of frames. And then it'll do the same thing for frames 2 to 6, 3 to 7, 4 to 8, and so on. This is just to try to reduce the noise level in the data so we get more accurate measurements of the radius of gyration and molecular weight. If you want to do it for every profile, you can set the average window size to 1. So looking at the plot here, you can see that there's a region in the main part of the peak that's got pretty much the same RG all around. Then there's some tailing regions on either end where the RG is either too high or too low compared to the center region. We can change the calculated value and look at molecular weight by 2 different methods, either the volume of correlation or the Perot volume. We can also look at the I of 0, and then I'll go back to the radius of gyration. So most likely what's happening here on the sides of the peak is just that, as you can see, the intensity in this peak gets quite low. And so there's going to be very little signal from the protein. And so we can't really say anything about these wildly varying RG numbers, except that probably they're coming from the fact that the scattering profile is very low intensity and the automated determination of the radius of gyration isn't doing a particularly good job. In this case, because the signal is so low, it also indicates to us that we wouldn't want to include these when we create our final averaged scattering profile. So a single monodispersed peak should display a region of flat RG and molecular weight across the peak, with possibly some spread like we're seeing here from low intensity regions on either side. RAW can automatically try to determine what that good monodispersed region is. To do this, what you do is you click on the Auto button in the sample area. So I'm going to click on that, and then you see again RAW plots this green region on the subtracted plot now. And this is the range that RAW thinks should be used for our data set. So what I'm going to do is I'm going to click on the Zoom button, and I'm going to zoom in here on the peak. And that lets us more clearly see the RG and the integrated intensity and what region RAW has selected automatically. You can see essentially what it's doing is it's avoiding these kind of varying ranges. It's avoiding the lower intensity parts of the peak, so it's hopefully not introducing any unnecessary noise. Again, with this region, if we want to adjust the ranges, we can tweak it by tweaking the start and the end. In this case, the auto has done a pretty good job, so I'm going to stick with what we have for that. going to zoom back out to the full plot. Once you're happy with the region that RAW selected, once we've determined what the good monodisperse region of our elution is, we say to profiles plot. So what that button does is when you press it, it averages all of the subtracted data, essentially, in that region that you've selected, and it sends that single averaged profile to the main plot. From there, we can do Guinea analysis, molecular weight analysis, everything we might usually do, and we'll do that in a moment. Before we leave this LC analysis window, though, what I want to note is that if you select a region that RAW thinks is not good, either for the buffer or the sample, it'll tell you. So for example, if I go back to this unsubtracted plot, and I extend the buffer range so it includes one of those peaks, the small peaks at the base of the main peak, like so, and I click Set Buffer. After I click Set Buffer, RAW pops up this window that says, hey, I found some differences in the selected buffer frames. Are you sure you really want to use them? And if you're not sure, you should cancel and you should re-examine the region that you've selected. So I'm going to cancel there. In this case, since we were happy with that initial buffer region, I'm going to set it back to where we were, which is 568. You can do the same thing for the sample. So I've gone to the subtracted plot. Say maybe we want to try to include all this data over here. Maybe averaging it will get us a little extra signal to noise. So I'm going to expand that region to the right side of the peak, and then I'm going to click To Profiles Plot. And you can see again, RAW pops up a window and it says, hey, here's a bunch of different reasons I think maybe this data shouldn't be included in the average. And then you can decide whether or not you actually want to go through with the average as you said, or if you don't. In our case, we don't, so I'm going to click Cancel again. And I'm going to set this back to where we were, which was 719. And then I'm going to click OK. So that profile, that average profile from the good monodisperse region of our peak, is now available on the Profiles plot and in the Profiles control panel. So you can see it down here on the subtracted plot, and you can see it in this Profiles control panel here. So if I right-click on this, I can select Guinea fit. We can do the standard Guinea fit. We can do the molecular weight analysis. And continue with any further analysis of interest. So this is how we typically process SEC-SAXS data. We use it to separate out larger things from the thing of interest or smaller things from the thing of interest. And then we have to average across that peak to get out a single averaged profile for our data set and use that for our continuing analysis. So I've gone back to the series tabs here. There's some more stuff that I want to work on. So I'm going to reopen the LC series analysis for this data set. You'll notice that when I reopen the window, RAW remembers all of the settings that we had, and it automatically propagates out these selected regions for both the sample and the buffer. So if I go back to the unsubtracted plot, as we noticed earlier, the buffer on the right side of the peak over here is a little bit different from the buffer on the left side of the peak. So we might want to add a buffer region over here so that we can average them together and use a single average buffer that maybe works better for the peak. So what I'm going to do is I'm going to click this Add Region button in the buffer area. It's going to add a new region that's initially this full range of the plot. Then I'm going to click on Pick. What this does is it lets me interactively set the region of interest. So as I move my mouse on the plot, you'll notice there's this vertical green line. I'm going to click initially, click once. That's going to define the start of the region, or one side of the region, could be the end. And then as I move my mouse out in either direction, you'll see that I get a region. I click again, and it defines the end of the region. You can see that that then appears over here in the series. It gives it the start and the end point where I clicked. And we can do some fine-tuning from there. The only thing I'm going to do to this is I'm going to adjust it to be the same length as the region on the start side. So we get equal contributions of each set of frames in the average. Now if we want to, we can click Set Buffer. And you'll see that RAW tells us, hey, there's some weirdness in these data sets. And we know that that's the case, because we know that there's a difference between the buffer. That's why we selected these two different regions. So I'm going to click Continue in this case. Now, if we take a look at the sample region here, I'm going to zoom in. You can see that this is maybe not the right sample region for this newly subtracted data. The RG's tailing off a little bit sooner, so I want to remove this old sample region. So I'm going to click just to the right of the pick button. You can see this now becomes highlighted in blue. And then I'm going to click Remove Region. That's how you remove a region that you've added. So now I'm going to ask RAW to automatically determine the range again. I'm going to click Auto. And you can see it's picked a slightly different region for the good range of the sample data using this buffer. We can click the Two Profiles Plot button to send this to the plot, and then we can compare it to the one we had previously and see how different it is. I don't actually want to save these buffer regions a new sample region with this data. I know that I like the first region better because I've done this before, so I'm going to click Cancel. That's not going to save any of the changes we've made, so if I reopen the LC series analysis window, you see that it's back to just a single buffer region and the initial sample region. So if I go to the profiles plot, you now see that there's another scattering profile. We can do the Guinea fit and the molecular weight for this one. And you can see that it's a little different. Previously we had 27.9, now we have 27.8 for the RG. The molecular weight estimates are actually quite similar. So in this case, adding in the extra buffer region doesn't really make any difference, which is why I'm going to go with just this single buffer region, because it's a little bit cleaner and a little bit more straightforward. So now I'm going to go back to the series control panel here. So just a quick note, if you want to adjust the color on any of these items in RAW, you can click on this color bar, and it pulls up line properties where you can adjust the line style, the width, the color, you can add data markers, any of that. You can also change the label if you have a legend. So that's just a quick little tip for you. One other thing that we can do from this series panel is we can take a look at either an average of the frames or some of the individual frames from our regions of interest. So for example, maybe I want to look at what the average buffer looks like. I just want to see that scattering profile for some reason. So what I do is I star this series here. Then in this data to profiles plot section, I enter the frame range of interest, which is 539 to 568. That was our buffer range. I'm going to select unsubtracted, and then I'm going to click average. That's going to average all the frames in that region, and it's going to send it to the main plot. So if I go back to the profiles plot, you now see that there's this single averaged buffer profile on the top plot, and it's showing up in the profiles control panel as well. So now I've gone back to the series plot. We can also send subtracted frames if we want, so maybe we want to look at the individual subtracted frames in our sample region, which was 693 to 722. 722. Change this to subtracted and click plot. Go back to the profiles tab. Now you can see I have a whole number of individual subtracted profiles showing up here on the plot. So the next thing that we're going to do is we're going to load in a different data set and do this all over again. So I've already shown you one way to load a series in RAW using the Plot Series button in the Files tab. RAW can also load in series automatically if the series was collected at a particular beamline. So RAW knows enough about data that comes from the BioCat beamline at the Advanced Photon Source and the macOS BioXTAS beamline at the Cornell High Energy Synchrotron Source that it can automatically load in data from those beamlines if you select a single file in the dataset. It knows how to generate the rest of the file names. So in this Load Online Mode section of the Series panel, you click Select. I'm going to go to the sec data and the sec sample 2 folder. I'm just going to double click on any, or single click and click Open, on any of the files in this folder. Doesn't matter which one. RAW automatically figures out all the rest of the file names in the series, and it loads in the series curve that you can see here in green. Note that you have to have loaded a configuration file from one of those two beamlines to do this, because that tells RAW how to load in the dataset. Most people will be loading in data that comes from a different beamline, and so you're going to use the plot series method that we used at the start of this tutorial. So note that once I've loaded in this green curve, I can't see the orange curve at all anymore. And this is because the scattering profiles in this dataset, which happens to be bovine serum albumin, which is a pretty common SEC-SAXS standard, the data files in this dataset, the scattering profiles, have a much larger scale than the scattering profiles in the other dataset. SAXS data can be presented on an arbitrary scale, and so this is what we're seeing here. That's because the scattering profiles are so much larger individually, the total intensity is also much larger. We can adjust these scale factors so that we can see both of them on the same scale. So what I'm going to do is I'm going to scale up the intensity in all the scattering profiles of this first series that we loaded in, called Profile. So to do that, I'm going to right-click on it, and I'm going to select Adjust Scale, Offset, and Q Range. That opens up this panel here, and with this you can adjust the scale for every scattering profile in the dataset, the offset, and the Q ranges used. So all we're going to do here is adjust the scale. I happen to know that if you apply a scale factor of 1800, which I've typed and then I hit Enter, if we apply a scale factor like so, it brings them to about the same level, so we can compare them pretty easily. I'm going to go ahead and click OK. Turns out that we're not actually that interested in the comparing these particular data sets, because I know they're very different proteins collected with different columns. So I'm going to go ahead and hide the data from Profile, this first series we loaded in. And now we just see the BSA data here on the plot. So what I'm going to do again is I'm going to just open the LC series analysis. I'm going to select the buffer region. I'm happy with the automatic. I'm going to select a sample region, send that to the profiles plot. So this is an interesting data set, in that what you can see here is the size exclusion column didn't fully separate out several things in the system. There's the shoulder, and then there's the main peak, and you can see that the RG has this very large value initially, coming down to about 28 from a bit over 50. The molecular weight similarly goes from about 180 down to somewhere around 65. And so the most likely explanation is that this shoulder is some kind of oligomer, maybe a trimer, given the molecular weight, and that's contaminating the results of our experiments. The other thing that I want to note is you see there's this kind of dip in the RG, and then it levels out on this edge. This could possibly be due to having too much protein in the system, too much protein eluting from the column, actually getting interparticle interference. And so you might be better off selecting a range that's over here, where it's noisier but flatter in the RG. And so these are the kinds of things you need to consider when you're looking at your data set. For now, I'm just going to click OK and continue on. So one thing to note is that once you've done the LC series analysis, information about the analysis shows up here in the information panel. So whichever one I have selected, I can select the profile series, I can select the BSA series. You can see the kind of some of the initial settings. You can see the buffer range. If we scroll down, we can see the sample range. So that's all there and available for you as well. If you want to export this intensity versus frame number in this RG plot, so you can say plot it for a paper or presentation, if you right-click on the dataset of interest, and you select Export Data, you then select a folder and you give it a name, so we'll call this BSA sec intensity.csv. It'll save a CSV file with all of that information. So if I now open a file browser, I can see there's the CSV file here. I can open that up in Microsoft Excel. And you can see that I've now got columns where we have frame number, integrated intensity, subtracted integrated intensity, radius of gyration, molecular weight, and so on. A value of -1 means that it failed to calculate a value for that range. So there's only going to be RG in the region across the peak. So if I scroll down far enough, you can see we've got an RG of 51, 43, etc. as it slopes down across the peak. And this now is in a nice spreadsheet format, and you can plot it in whatever your favorite plotting program is. I'm going to go ahead and close this, come back to here. So the other thing that you should do with the profiles once you've finished your analysis, or with the series once you've finished your analysis, is you should save it. So I'm going to select both of these, and I'm going to click Save. Then I'm going to just put them in the main sec data folder. So once it's finished saving, I'm going to remove them. And if I go to the Files tab and I go up a level to the main data folder, you can see there's this BSA and profile HDF5 files. These HDF5 files are raw series files. If I just double click on it, you'll see that it loads that series back into raw. It has the integrated intensity, has all the RGs. We can go to the series tab. If we open up the LC series analysis, we see that it's saved our selected buffer and sample ranges. And so all of that analysis is very easy to pick back up right where you were, or come back and tweak a little bit as long as you've saved the series file. So with that, that's the end of the tutorial. You should now know how to do some basic analysis for SEC-SAXS data using RAW.